Wanted to show you an example quickly of kind of how a North American electrical print is laid out. So I'm going to zoom out here. This is just a sheet out of a machine that we're building. It's just a little bit of a small panel layout. There's about 5 sheets for this job. I'm going to show you this one sheet. We have our title block down here in the corner. Our revisions are up here. Okay. And then this is the general layout. Now, like a European style print, you would see sort of like an atlas, kind of an A, B, C, D, E, F across the top maybe, and a 1, 2, 3, 4 down the side. What we have, at least where I work, and this does work pretty well. There's really not a lot of, I don't have a lot of issues finding things. And honestly, I don't have a lot of problems finding things in the European style. It's just different. What we use is, this is sheet number 50. You can see up here, it's electrical sheet number 50. And it's revision number 1. Okay? So what you have is line 50. I'm sorry, you have line 01 of sheet 50. So you can see that, right? So that's what this is. 50 line 10, 50 line 11, 50 line 12. And what happens is this breaker is essentially page 50, line 1 circuit breaker. All right, 14 gauge blue wire, and wire number, this is sheet 50, line 01, wire number 1. I'm using the top of this crosshair to point. Okay, so this is wire number 1. There's a circuit breaker. Now, kind of in our tradition, this one's a little special, but it doesn't matter. We would normally have our power as wire 1 and our ground as wire 2. So that is why they chose, that's just sort of a convention that we have at where I work. So that is why wire 2, you can see right here, okay, or right here in the center of the crosshair. Wire 2 is going to be the ground, or the common, or the 0 VDC. That's going to be a white with a blue tracer. Okay, and then they went back and they said, well, between the breaker and the actual power supply is wire number 3, which you can see right there. Okay, so now you have 3 different wires. Moving down, you can see a cross reference, or a bubble here. So line 276 is 120 AC coming into this sheet. All right. So that is feeding this power supply. And this power supply gets its power from here into the line pin here. Now, where is line 276? Well, the convention we use is 2 numbers for the line number, because if I bring you down and show you, there's 2 rows. There's this row of lines, and then there's this row of lines. So the way this is laid out, you only get to 84 is the total, because at the back here, there's no more rows or columns, sorry. So 84. So now there's only 2 numbers for the line number. So what it's telling you is sheet 2, and then it's line 76. So if I were to go to sheet 2, line 76, I'd probably find a transformer or something, or maybe possibly a circuit breaker that's supplying power, because you see there's no circuit breaker before the power supply, so probably there's 120 going through a circuit breaker that ends up coming out to here. And you can see that it is wire number 1 from sheet 2, line 76, going in. And the neutral is from sheet 2, line 76, and the wire number is 249, wire 2. So most likely, sheet 2, line 49 has a transformer on it, and wire number 2 on the transformer is the common, okay, for the AC system. Yeah, you can see right here, there's the common. All right, so we're going to a receptacle. This is the dotted, the dash here is telling me that it's remote and that it's this, every component inside it is within the unit. All right, so I have a 3 amp breaker. Now what that is basically a GFCI test reset type button thing. That's just what this is showing. It's just saying, hey, on the side of this machine panel, or at least maybe the operator pendant, there's an outlet, and they use it for their radios or their fans or whatever. Generally, it's supposed to be for programming purposes, but we're not out on machines all day. So you can see a Mencom brand programming port. Further down, this is all on the DC line. You've got another circuit breaker, and you can see it's 50 for sheet 50, 22 CB. So it's 5022 line, and then it's circuit breaker. Okay. Then you can see 5022 1 is the basically wire number 1, and it's powering up a PLC. Solid circles are connections. Okay. And basically we're just showing mod power and SA power getting provided by this circuit here. And then you can see a bubble over to 5301, which means power from this circuit breaker goes to sheet 53, line 01. So if we were to open that up, you would see way up at the top of the sheet, you'd see a bubble here that probably says 5029. All right, so let's just go do that real quick. So we're going to go to sheet 53. And there you go, 50221 wire from 5029. Okay, so let's go back. 50221 going to 5301. All right, so that's how the cross references work. Now, the power and the ground are both sent out there. So you can see 5301, same bubble. If we go back, 5301, you can see right here the DC COM is also sent to this input card. Okay, basically we're interfacing a Modicon to an Allen Bradley. So it's, you can see the Allen Bradley input card here, and then the Modicon outputs are noted here, and they come from sheet 18, line 27, 29. So this is a Modicon output, sheet 18 is. And we're programming all these particular Modicon outputs with these descriptions, okay? So on an I/O sheet, normally you'd see the power, the input source, the actual input, the common. All right, that's because it's sort of a standard of ours to put the common on here. Now, if you had like a switch, like a 3-wire prox, technically we're supposed to draw the 3-wire prox, the prox or the limit switch, and then put a wire all the way to ground. All right, for the blue wire. On the drawing, we do not do that because it gets messy crossing the input card with all those wires. However, it's inherent, and it has to be there for the for the switch to work. Usually it's a proximity switch, like a metal prox. So That's how that is laid out. Um, Going further, you can see a switch here. V1 plus, V1 minus. A lot of times switches have two different power sources. You can wire them from different power sources if they're critical. And you can see some bubbles. We're on line 5042, so 42 line of sheet 50. And you can see that we label 24 VDC wire number is going to go to sheet 5043, which is the next line. Well, where is that line? They're both doing it. So come on up and you're going to see right here. All right, so even inside the sheet, we're doing cross references, so you can always find where you're headed. Let's go down to the bottom of this. Okay, let's go down here to the bottom. And you can see that we end the 24 volt distribution system here. Okay, so we put end, or you can put dashes, or you can just put a bubble with nothing in it. But effectively, it's saying that there's no more sheets with 24 volt distribution on it that are using this rail. Now, there could be bubbles inside of here, like these bubbles, right? They're going out to other places. But as far as the main distribution layout, there isn't any more of this particular 24 volts. Sometimes you send out 24 volts through a safety circuit, and that creates a second kind of 24 volts. All right, so then in that case, what ends up happening is 50011 24 volts is just 24 volts. But if there was a safety relay right in here, and there's an outputted 24 volts from it, that would get labeled in this area over here as like hazardous motion or hazardous output power, and then it would get used to control, probably, in our case, it would probably be PLC output cards would be given power when that is made, or when that particular power is on, so that if a safety gate or a light screen or whatever, or an e-stop is pressed, that loses power, and then all the hazardous outputs are killed, let's say. So that's usually an air cylinder. That power goes out to an air manifold or a laser system, whatever. Okay, so that's kind of how these are laid out. I'm going to come out a little bit. You can see the equipment, like this PLC is 5021 PLC. Well, on the machine itself, there would be a label, a printed vinyl label that says 5021 PLC on or next to this 5380 PLC, okay? And that would tell me, hey, it's on sheet 50, line 21 is how, where I can find in the electrical print this PLC. Or let's say that this 5016 receptacle isn't working, and the resets and stuff aren't working. And I say, well, okay, where is it? Well, it's 5016 receptacle. All right, let's go to sheet 50 and figure out what's going on with this receptacle. Okay, so maybe you track it back and you find out that this isn't working. This may be not a great example because this probably isn't working either. But if you had a broken wire, you'd know where to hook this up to with a repaired wire, let's say. So that's how you read a sheet, at least where I work. Okay, I just wanted to kind of get that off my chest, I guess. You do find these that only go to maybe 42, where there's a lot more room between them, or you'll find them that go to 30. It doesn't really matter how many lines there are, because sheets should not get too busy. These sheets here are not terrible, but don't make your sheets too busy. This is not printed on letter size paper. This is printed on 11-inch by 17-inch paper. All right, 11 by 17. This needs to be big, easy to read. Okay, this is part of a design job, so you can see we bubble in new sheet, and when this is released to our reprographics or blueprint room, this will be cleaned up. All right, but this is a signal to tradesmen and constructors that, hey, this is uh, the new design, and this is work that needs to be done. All right, because when it's printed out generally in black and white. So, all right, call that good.